This video is about exponential equations and intro to logarithms. So this is the equation we have. It says solve the equation for x, and what we have is 6 to the x power equals 216. Now, this you can solve without logarithms. We're going to talk about what logarithms are in just a minute and why they're useful. But sometimes you can solve equations just using exponents. For example, you should recognize 216 as being one of the perfect cubes in our perfect cube list. So this is really 6 to the x power equals to 6 to the third power. Alright, so if you get both of these numbers, the bases being the same, just for the record, this is a base. So when I say base, that's what I'm referring to, and then x would be the exponent. The exponent on 216 right now is 1, and you generally don't write it there, but that's what it is. Then we'll rewrite it as 216 as 6 to the third. Well, now it's 6 to the third power. And technically 6 to the third power to the first, because that's power 216 is being raised to. But truthfully to the first, you don't have to worry about very much. So we have a 6 to the x equals 6 to the third, because the power to the power you multiply, so exponent is 3. So if that's the case, what we have is 6 to the x equals 6 to the third. If both of these bases are equal, if the bases are equal, then the exponents must be equal. So if that's true, this exponent has equal to this exponent. So x has equal to 3. So we solved it. 6 to the third power equals 216. That's a really easy one though. You probably think, that was easy. I could have figured that on my own. So let's make it a little different. Okay, so new example. And this one says 15 to the x plus 1 power equals 225 to the 2x subtract 3. So basically what you want to do is, this base is 15, and you want to get this base to try to be 15. So if you think about it, 15 squared is 225. Again, that comes out perfect squares as well. So I can rewrite this as 15 to the x plus 1 equals to 15 squared, and that's raised to the 2x subtract 3. Well, what we know is about the power rule says power to a power, we multiply the exponents. So this 2 has to distribute both of those, giving you 15 raised to the 4x subtract 6 is equal to 15 raised to the x plus 1. Now that we have both bases being 15, exponents must equal to each other. So I know for certain that x plus 1 has equal to 4x subtract 6. So I'll write it over here. X plus 1 must equal to 4x subtract 6. And it's a simple equation I can solve. I can subtract x on both sides. Given 1 equals to 3x subtract 6. Add the 6. And you get 7 equals to 3x. And of course you divide by 3. And you get x is 7 divided by 3. Which is a long decimal. I think this is 2 1/3. So 2.3 repeating. So we know x has to be either 7/3 or 2 1/3. Either way. Or you might write 2.3 with a bar on top. So in that case, you can solve it using exponent properties. So those are some of the properties of exponents. And that's how we actually solve it. Give you one more like that one. Okay, so a new example says 2 to the x subtract 1 equals to 8. Take a minute, write it down, see if you can solve it. So I'm going to let you pause the video, write it down, and see if you actually solve it without my help. Alright, so if you gave it a try, you should have rewrote. You should have recognized 8 as being 2 to the power. 8 is really 2 to the power of 3. So if that's the case, I know that x subtract 1 has equal to 3. X subtract 1 equals 3. That's pretty easy to solve. You add 1 on both sides. you get x equals a 4. So I can check it. I can plug it in. Let me see if it worked. That would be 2 to the 4 subtract 1 equals 8. 2 to the 3rd equals 8. 2/3 is 8. So 8 equals 8, and it's true. Gives a true statement, so it worked. So that's how we can solve exponential equations without using logs. Now, let's look at some that you can't really solve using anything you know so far. So get this as noted if you need it. I'm about to erase it. All right, here's a new equation. So solve the equation for x. We have a 7 to the x equals a 9. So you got to think about this. 7 to no whole number is going to give you 9. Because think about 7 to the first power, is 7. 7 to the second power, 49. And already, you're way bigger than 9. It's not even close to it. So whatever it is some decimal power you have to raise it to. So if you didn't know any of these rules that I'm about to teach you about, you can kind of guess. You can kind of play with numbers. You can plug in numbers like 7 raised to the 1.5 and see what happens. I got a graphing calculator online, so I'm going to show it with that. Let's see what it is. So I can type in 7 raised to the 1.5. And let's see what it is. It's 18.5. Way bigger than 9. So you know you have to choose numbers that's less than 1.5. So let's guess again. Let's say 7 raised to the 1.1. And it's 8.5, a little closer. So let's guess again. 7 raised to the 1.2. And already you're above it. You're bigger than 9. You're at 10 now. So you know it's somewhere between 1.1 and 1.2. So you got to guess some more. 7 raised to the 1.15. Let's see what that is. And that's pretty close to 9. It's 9.3, but I have to get closer than that. That's not a good estimate. Let's try something else. 7 raised to the 1.12. 8.49, so it's too small. 7 raised to the 1.3. Too big. 7 raised to the 1.125. 8.92, a little closer. Still not good enough, but I'm getting a good guess that x is like 1.1 something. I don't really know what it is, but it's definitely 1.1 something. So I'm gonna get one last guess. Say it was 7 raised to the 1.126. And it's a little closer. All right, so you can play this for a while. I'm kind of giving up on this. I just know it's 1 point something, but I can get a better estimate using logarithms. So let's go back to it. All right, going back here. Instead of guessing, what you can do, and you can get an estimate after a very frustrating time of guessing and checking for a while. The way we can solve this is we can use logarithms, which is a new thing. Basically, what you can do is you can take the log of the left side of the equation and log of the right side of the equation. Now, there's a log button on your calculator. If you look at your calculator, you're going to see a button that says log. There's a property of logs that allows us to say that if this is an exponent, the exponent has a right to come down to be in front of log, making it x times log of 7 equals to the log of 9. The log of 7 is a number like any other number, so I can divide both sides by it. So I can take this equation that says x times log of 7 equals to the log of 9. I can divide both sides by the log of 7. So this log and that log cancel out to be 1. Giving me x is equal to the log of 9 divided by the log of 7. What you can plug into your calculator. You find a calculator, you type in log of 9. You may want to make sure everything on top goes parentheses. You might put parentheses log of 9, then divided by parentheses log of 7. So it doesn't misunderstand you. Let's go find out what that is now. Alright, so most calculators, scientific calculators, graphic calculators, can have this log button. So let's go find out what this is. Log of 9, close parentheses, divided by log 7. They enter. Answer is 1.1292, basically, or 1.12915. That's a pretty good answer. We were pretty close. We got 1.9, but if I choose the 1.5 there, I would got an even better answer. Let's see. Let's say x was 7. Let's say x was 7 raised to the 1.12915. Let's check it out. So 7 raised to the 1.12915. And we get 8.9999998. Now that's a heck of a close answer to 9. That's to the tens, 100,000, 10,000, 100,000s. That's like 2 millions off from 9. That's a really good answer. So x is definitely what we said it was here, 1.2915. All right, so now let's actually solve more of those equations. So for the record, x equals the 1.12915. About. It's about, because we didn't write all the decimals. We just chose stop right there. So anyway, that's a pretty good answer for x. All right, let's solve another one. So I need to erase this. All right, so suppose I gave you this one. 22 raised to the x subtract 1 equals to 4. So automatically, you know, this is not something you can just solve using your understanding of exponents. So now you have to understand, well, how can I get this exponent down? Because the problem is, there's an exponent that's up there. Had it just been 22x subtract 1, you add 1 divided by 22, you're done. However, in this case, the exponent has a variable, and we don't want that variable to be up there anymore. Now we have a way of getting it down. We take the log of the left side, and take the log of the right side. By taking this log, this exponent has the right to come down and be here. Make it an x subtract 1. I'm putting parentheses times log of 22 equals to the log of 4. And this is really solvable. If you have x subtract 1 times the log of 22 equals the log of 4, we can divide both sides by log of 22. So these cancel to be 1. So what we have is x subtract 1 times 1, which is x subtract 1, equals to the log of 4 divided by the log of 22. And our last step is to isolate x. So I have to add 1 to the other side. And our answer is x equals to the log of 4 over the log of 22 plus 1. So you need a calculator to figure out what that is. Plug this calculator and see if you plug it in and get the same thing I get when I plug it in. Alright, so what I got was x is about 1.4485. Had to round up. Generally go out 4 decimal spaces, so I stopped at the 4th one. So 1.4485. I plugged it in and I checked it, and it actually worked. It gives you something really, really close to 4. So that's what it is. That's how we actually solve them. All right, so we'll talk about doing one more type, and that's going to be using natural log instead of regular logs. So here's one new one. So the new equation is 9 to the x equals 15. So instead of taking the log of both sides, we can take the natural log of both sides. The natural log is also your calculator. It's written as ln, and it's basically a log. A regular log of some number b, has a base of 10 right here. It's not written, but it's understood. So the understood base on any log if it's not written there is 10. Natural log has a base of e. So this is log base e of b. E is a number that's in your calculator. E to the first power is about 2.71. It's an irrational number that comes from someplace in math. But anyway, so that's why we use natural log sometimes instead of regular log, because it is the same thing. So anyway, this x comes down, making the x natural log of 9 equals to the natural log of 15. You probably already know you're going to divide by natural log of 9. So x equals the natural log of 15 divided by the natural log of 9, which is about 1.2325, roughly. So that's the introduction logs and exponential equations. That's all I have. Good luck.